Welcome back to lesson 2 for circle properties. Circle property number 1 is the tangent line theorem. One thing I want to start off talking about before we do anything is we're going to learn a couple of theorems in this unit, and theorems are proven facts. Okay, so some time ago someone measured these situations that we're going to talk about. They found that they could prove them to be true every time, and when you prove something to be true every time, it becomes a theorem, and you can use it to prove other things true. So that's what we're going to do. We're going to learn some theorems, and then we're going to use those theorems to solve other parts of the circle. And that's basically our goal for the whole unit, right? Solve unknowns in circles. So we start with the tangent line. It was in our vocabulary list yesterday, but just to repeat it again, a tangent line, a line that intersects a circle only one time. So we have our circle, and we can have any line coming through, and it's going to just touch that circle in one spot. Okay, and it can look different. It might look something like this as well. Okay, there's my point of tangency. You see that definition just below. Point of tangency. Okay, that's the point that it touches the circle. When we're naming lines, for simplicity's sake, we use letters. So we could say that line segment AB is tangent to the circle. Okay, that's how we would write a line segment with the line over top of the A and the B. So you're going to see those notations quite a bit. All right, so that's the line that intersects the circle one time, and the point of tangency, that's the point at which a circle intersects a tangent line. All right. Okay, so the tangent radius property. This is the property that we're learning. A tangent to a circle is perpendicular to the radius at the point of tangency. So this is the big deal right here. This is the piece that we need to know. This is the point that has been proven already. Okay, a tangent to a circle is perpendicular to the radius at the point of tangency. So if I maybe just go back up to my circle here, if I were to draw a center O, and I drew a radius and met right at that point of tangency, this theorem states that that is then a 90-degree angle, because we say those two lines are perpendicular. The same can be said over here. If I drew a radius to the point of tangency over here, then that would be 90 degrees. Why is that relevant? 90-degree triangles are important. We know the Pythagorean theorem. We're going to use that quite a bit in this lesson. All right, I could draw in 90-degree triangles like so, and then I can start using some measurements and figure out some missing information. Okay? All right, so some examples start here. We have point O is the center of the circle, and AB is tangent to the circle. This given information is important and relevant, because remember, we never assume anything from the diagram. And what I want to point out about this diagram is that right now, there's no indication of a 90-degree angle on the diagram, but because we've been given these two pieces of information, we know that AO is a radius. Okay, AO is the radius. Then AB is tangent. That's point A right here. There's the point of tangency. We can then say that AB is perpendicular to AO. Okay, and because we know that, we can draw in the 90-degree angle. Okay, so angle OAB is 90 degrees. I don't know if we've talked about how to name our angles enough, but just in case we haven't, I want you to notice that the middle letter represents the vertex of your angle. Okay, so that middle letter is sort of the vertex. And I like to think of these sort of as like roadmap directions. Put your pen on O, go to A, up to B, and that's how you get your angle. Okay, so angle AOB is 90 degrees. That tells us quite a bit then, because that makes triangle OAB a right triangle. so we're asked to find angle OBA. So angle OBA. Again, if I use my little roadmap instructions, I do this in green. I'm going to erase these now. So O to B to A. So from O to B to A, I'm trying to figure out what that is. I still know that that's 90. All right, so I know that this angle in here is 90. I know this angle right here is 63. How do I find a third angle? Well, remember from our review lesson that we can take 180 degrees minus 90 degrees minus 63 degrees, and we end up with our missing angle. That would be 27 degrees. Okay, so I want you to get in the habit of making final statements. Angle OBA is 27 degrees. Okay? Alright, so we used some of that knowledge we learned yesterday about the sum of three angles in a triangle. And once we know that that angle is 90 degrees, that makes this problem a lot simpler. Okay, so look for those problems. You're going to see that quite a bit where you're going to be given two angles and have to find a third. Alright, next example. Alright, again, we're given lots of information. So point O is the center of the circle. So when you're given the center of the circle, we know that that means we have a radius. So we can say, what's the radius here? Think about it for a second. If I asked you what the radius is, you would say O to C is the radius. Okay, so O to C is the radius. We see that CD is tangent. Okay, so CD is tangent. There's my point of tangency. And because CD intersects OC, we then know that OC is perpendicular to DC. Okay, and because they're perpendicular, we can draw in our 90-degree angle. I haven't said this yet, but it's actually a really important fact. You need to draw on your circles. And I understand that it's frustrating when you're using your textbook because we don't want you drawing in your textbooks. But on your notes, and anytime you have a chance to just re-sketch the circle into your notebook, it is worth it because you want to draw on your circles and add information. Okay? All right, we've been given other things. We've been given CD is 15 and OD is 20. So there's my two measurements that I know. I'm trying to determine the length of the radius from O to C. Okay? Well, a few things are going to help me here. I want you to see that I have triangle OCD, and it is a right triangle. Okay, I know it's a right triangle because there's a 90-degree angle in it. And how do you find the missing side length of a right triangle? Well, we have this awesome formula, Pythagorean theorem, to help us out. So we're going to use the Pythagorean theorem. Now, to use the Pythagorean theorem, we have to identify the longest side, right? We always know that that C represents the longest side, or the hypotenuse. And the longest side is always opposite the 90-degree angle. So draw your arrow right through that 90-degree angle. That's your longest side. Now, you have two options here, and I'm going to show you both. Some people just like to know C squared equals A squared plus B squared. Therefore, they will do this, okay? They will just replace the letters as they see them. 20 squared equals, now A can be either, or 15 can be either A or B. This makes sense to make it the first one. And then set up their formula like so. Subtracting the 15 squared to the other side. So we end up with 20 squared minus 15 squared equals B squared. Put that in my trusty calculator here. And I end up with 175 equals B squared. All right. Now, is this the final answer? Would this be acceptable as the final answer? Hopefully you're all saying no. We don't want B squared. We want to know what B is. So we need to remember that to undo the squaring operation, we use square root. So I take the square root of both of those sides, and we'll go to the nearest tenth of a decimal. Always read the instructions. I did read mine. Nearest tenth, so we're good. 13.2 centimeters, I believe. Yes. Don't forget your units. 13.2 centimeters. Now, some of you are probably thinking, well, okay, I understand what you've done, but I would rather use a different version of the Pythagorean theorem. I just want to start with a shorter side formula. And you can just start with the formula already adjusted. So if you're comfortable with that and know that that's what the Pythagorean theorem works like when you're looking for a shorter side, then you really have the same work as I just did. Maybe it just seems a little less when we get the same final answer. Important to understand, if that makes sense, 13.2 centimeters definitely should be smaller than 20 centimeters because 20 centimeters is the longest side of that triangle. So definitely check your answers to make sure they make sense. That's another good reason why 175 doesn't make sense. It's clearly too big for the situation. Circles are never drawn exactly to their specific measurements, but we need to be able to be reasonable and understand that 175 centimeters just doesn't make sense. So this is the second type of example, and really it's just solving right triangles. We use the Pythagorean theorem to find a missing side, okay? So the base circle theorem that you've learned today is that a tangent line intersecting the radius creates a 90-degree angle, which makes those two lines perpendicular. That just helps us get to 90 degrees, then helps us solve our triangles, okay? All right, so here's sort of a real life application question. An airplane A is cruising at an altitude of 9,000 meters. A cross-section of the Earth is a circle with a radius approximately 6,400 kilometers. A passenger wonders how far she is from a point H on the horizon she sees outside the window. Calculate this distance to the nearest kilometer. Okay, a few things to point out when we're reading the problem. I hope you picked up the difference between 9,000 meters and 6,400 kilometers. Okay, so 9,000 meters and 6,400 kilometers, we're using two different measurements and we can't do that. So I'm going to suggest we take 9,000 meters to change that to 9 kilometers right off the start. Okay. Let's pay attention to our circle. You'll notice that the word tangent isn't in the problem. We haven't said that we have any tangent lines, but we do have to use our limited knowledge maybe of science here, hopefully we get it, but we understand that horizon, the H, stands for sort of that one point where you can see the sky connect with the Earth. That's like a tangent line. It's like that one connection point to the Earth. So I do have a point of tangency at H, which makes this AH a tangent line. Okay, so there's my tangent line. See what I mean about drawing? It's nice to be able to draw things on here. We're missing, or what we're trying to figure out is the distance. This distance from here, A to H. I'm going to put a little X here because that's what we don't know. All right. Now, do you see a triangle? I don't see a triangle, but the best advice I give you is draw a right triangle somewhere. I have a radius. Here's a radius here. It's kind of hiding. So from the Earth to the edge, that's 6,400 kilometers. That's a radius. But I need another arm for a triangle. Well, if I do this, join the center of the Earth to the horizon, I've just created another radius. I know the radius, 6,400 kilometers, because the radius is the same throughout the circle. Okay, so I already have a radius, 6,400 kilometers. Okay, I know that this combined side length here, okay, now that I've changed 9,000 meters to kilometers, it's 6,409 kilometers. And now I have a right triangle. How do I know I have a right triangle? Point of tangency connected to the radius. There's my radius. There's my point of tangency. That's my 90-degree angle. Okay? Good old Pythagorean theorem. I have the longest side already. So my 6,409 kilometers is my longest side. I'm going to go right into the subtraction version of this formula. So 6,409 kilometers is the longest side, squared, minus 6,400 kilometers squared. Definitely need our calculators for this guy. So I'm just going to get right to a squared. So in my calculator, I'm taking 6,409 squared, and I'm subtracting 6,400 squared. And I end up with 115,281. Now again, go back to the top of the question. We're going to the nearest kilometer, so that's the nearest whole number. So 115,281, that doesn't make sense, but I square root that answer. And I end up with, to the nearest kilometer, actually I'll give you a couple decimals here. I end up with 339.53, but if I'm going to the nearest kilometer, that's going to be 340 kilometers away. All right. That's how we solve that word problem. Okay, that's really the end of my examples. Sorry, you'll notice that you have this question 3. This is part of your homework for tomorrow in class. You don't have to worry about that. And you'll notice that one extra page here, and it says use this page to make notes from any other videos you watch. I encourage you to watch a few extra videos that I'm going to attach in your email so that you can get a little bit more practice on the tangent property, but I want to stress that it is not very difficult. The biggest point here is I have a circle and I have a radius, and if I have a tangent line, so let's say that's point A and there's point B, and if this is O, and if I tell you that OA is tangent to OB, I think I did that wrong, sorry guys. AB is tangent. AB is tangent to OA. You can then do lots of things, right? We then know that angle OAB is 90 degrees. Okay, I can add in an extra arm here to make a right angle triangle. Now I have triangle OAB. It's a right triangle. And as soon as I know that something's a right triangle, I definitely can bring in the Pythagorean theorem. I also know that I can find a third angle by subtracting 180 minus 90, which is my given angle, minus, let's say, we'll call this one angle 2, and that would give you your last angle, angle 3. Okay? So I encourage you to try those other lessons, and we can talk more in Friday's class. Okay? Thanks, guys.